is. It's undefined. And you know what? Undefined, when we graph it, does something to our graph. Now, we're going to have to think back, oh, God forbid, 3 months. When we have a 0 in a fraction, it makes a weird thing show up. Does anyone remember what that weird thing that shows up when you have 0 in the bottom of a fraction? Begins with an A. An asymptote, or as Mrs. Tarantino calls them, lava line. We got lava. Holy crap, we got some lava. Throw some lava in there. Good? Okay, going on. We're going to this guy. Okay, now I'm a little shaken. I'm a little rattled. I'm not going to lie. I was good with the 0. Undefined kind of freaked me out. Okay, phew. I got 0 divided by -1. That's 0 again. I'm feeling better. I'm feeling better. Okay, I got a 0 right here. Then I go to this guy. Oh no, I got -1 over 0. I got that undefined thing again. Guess what it's going to be? Another lava line, another asymptote. So throw it in. Well, I head back around the circle and look what happens. Another 0, yay. And then another stupid lava line, another stupid asymptote. And guess what's going to happen on the next one? We're going to hit 0, and we're going to hit another lava line. Every time I'm at anything divided by 2, I got a lava line. Now, if you remember what lava does, it means you can get really close to it, but you can't touch it. So here's what our tangent does. He's like, la, 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 la. I'd like to do that. Remember, these graphs are all wavy. They're all nice and wavy. He's trying to do the little wave thing, and he comes up against lava. And he's like, oh, no. And he goes like that. Well, he thinks, well, maybe I can get out by going down instead and being free that way. And guess what? He tries. He's heading down. No, more lava. Yep. Guess what? That's tangent. He does it again. I'm trying to get out. I can't. Maybe I'll try this way. I can't. He tries this way. I can't. He tries this way. I can't. This is a periodic function because look, it keeps doing the same thing over and over. He goes up here. He goes down here. And you have now just graphed tangent. Is he crazy looking? Yeah, he's kind of beautiful, to be really honest. But that's why he works that way, because the stupid lava lines trap him. He tries to get out. He tries to be like a nice little curve, but he gets trapped and it doesn't work, right? So here's what I'm talking about. If you understand how the numbers work, you can do anything. So we now are going to try to do y equals the tangent of x plus 3. So here we go. Same bottom every time tonight. And on the homework, I even wrote this for you. Pi over 2, pi. I'll be honest, the hardest part is this, is just putting these on here because they're such a pain in the ass. But, sorry, people at home. 3 pi. 7 pi. I always forget him. 7 pi over 2, 4 pi. Okay, I think I heard Jace already tell me what I'm supposed to do. My lava is in the same places, right? Anything that divided by 2, I'm still going to have lava here. Lava, and lava, lava, and lava, and lava. Oh, no, lava's over here. So remember how I crossed at 0, right? But now it's not going to be 0. It's going to move my midline up to 3, right? So I just take this dude, I just shift it to 3, and now watch what happens. He crosses here, and 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 he tries to escape. Make him escape. Can I please get out? Oh, I'm trapped. Trapped. I'm trapped. I'm still trapped. 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 Which is crazy. That's a crazy looking thing, and you guys totally get how to do it, because once you get the shape, you just move it around. So easy. Love tangent. He's one of my favorites because he's pretty. Yeah, we feeling okay? Yeah, you got this. Here comes our next one. My next one, super favorite. The whole reason I like teach a trick. We're doing this guy, y equals the cosecant of x, and you're like, what? Here's what I want you to do. First thing, step one, please put our numbers on here. Please put our numbers. Let's start there. Nice and easy, nothing scary. Get these on here. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 8 pi. Oh, knew that, trusting you. Okay, now I'm going to walk around because I want you to do something for me. I want you to use a pencil if you have one. If you're using a pen, that's cool, but maybe make it dotted. I don't want you to graph cosecant. I want you to graph very lightly y equals his partner sine. This is from yesterday. It should be super easy. It should not be hard or scary. Just do sine. Nice and easy. We're going up one and down one. Just nice and easy. I'm going to walk around. Put your dots. You remember he starts at 0, goes up 1, middle. Oh. There it goes. That was scary. Middle, down, middle, up, middle, down, middle. Draw it in nice and softly. You know what I'm going to do? I'm going to use a dotted line, and it's going to look really cool, and I'm going to be impressed with myself. Watch what he can do. No, it doesn't have to be dotted. I'm just doing it so you guys can see what I'm doing. It just looks cool like that. Okay. That's sine. Now, here's what's cool. Cosecant is kind of, imagine that we're going to the upside down world in Stranger Things, right? It's kind of the inverse of everything. So the first thing is, wherever he hits 0, now is an asymptote, right? Because it is flipped into the upside down world. So the first thing I want you to do is throw in some asymptotes, some lava lines everywhere this guy hits 0 or the midline, right? So throw in some asymptotes. Throw in these guys. Throw in these guys. Now, sine doesn't have any asymptotes, but cosecant does because he's in the upside down world, right? Now, here comes the best part, the big finish. It is the inverse of sine. So watch what he does. I want you to think of it like kissing a mirror. When you go to kiss a mirror, like you are the mirror image of you, but you're touching right at the mirror. So watch what he does. He's gonna be the, see how he's going down? He's gonna go up, but because of the lava lines, he goes up forever. Now he's gonna come down here and he's gonna kiss down here. Up here, he's doing that little practicing kissing thing to see if you look weird when you go in for a kiss, and you all do. He's gonna do it right here. And he's gonna, because everyone does, down there. Guess what? Those red ones, that's secant. That's secant. I mean, that's cosecant. You just graphed cosecant. It's the coolest graph ever. Because all you really need to do this graph, I'm going to show you how to do this graph a little bit faster. Watch this. Watch, I'm going to go super fast. I'm going backwards, so I'm taking, oh, no, get out of here. Watch this. I'm going to make this super nice. Watch what I do when I graph it. I put on sine, and I know I have an asymptote here. I don't even draw it. So Tim, look, I'm not even drawing it in. All I know is where my asymptotes go, and then those I think of as my kiss points. So I kiss right here. Oops, he's actually right here. You kiss right there, and I kiss right there, and I kiss it right there, and I kiss it right there. And guess what? I've just graphed cosecant. So easy. So here's what's up for you, lambs. Without me helping you, can you graph secant? Here's the hint. Put on cosecant first, because that's his, or cosine. Do him. Find your asymptotes. Find your kiss points. Draw it in. Give it a try. It just shifts your asymptotes, right? The asymptotes are wherever cosine touches the midline. So remember, on the cosine, he doesn't start on the midline. He starts at 1. So, you know, on the other one, the asymptotes were at 0 and pi and 2. Right. Right, that would be an asymptote. And, right, put that dot, put the dot at the bottom. And then asymptote, good. And then, good, asymptote, bottom. And then stop, you've got enough. Draw your kiss dot, draw your U's. Yep. Down. And the only difference between it and sine is that sine, the asymptotes were here, shifted over. Does that make sense? How does yours look? I'm going to show you mine. Yes.
What are we doing?
We're doing secant.
Okay.
So that means let's put our stuff on for cosine, because that's his partner. That's his guy in the upside down world. So right, cosine, y equals cosine x. That's what we're going to start with him. Okay, so let's think of what cosine does. It starts at 1, dot here, dot down there, dot there. Awesome. Keep up. Don't fry. I always forget the midline. When you go up, oh, you're right. Yeah, sorry, that was me. Good and good. Awesome. So good. Now, everywhere he hits the midline, that's our asymptote. So draw it in. Boom, 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 boom. Keep on going. And everywhere you have a dot is a kiss point. But
Okay.
remember, he goes the opposite direction. So normally he would go like this. So this guy's going to be up here. Boom. Boom. You just draft secant.
Right.
I told you, secant's cool. Here we go. Pi over 2. Pi. 3 pi over 2. 2 pi. 5 pi over 2. 3 pi. 7 pi over 2. 4 pi. Okay, shh. Hold on the speaker here. Okay, so here's what I do. Honest to God, I put the dots for cosine. They are my helping points. My dots for cosine go like this. If that's 1 and that is -1. It's dot, midline, dot, midline, dot, midline, dot, midline, dot. Step 2, throw those asymptotes in. Now, Talia, here's what happened. When we did sine, the lava lines were on the whole numbers. 0, 1 pi, 2 pi. Does that make sense? But on secant, they shift over to the halves. So asymptote, 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 asymptote. And now you got your little kiss points, your little reflections. So boom, there's 1. Boom, there's 2. Tim, are you good? But do you understand it? It shifts over because normally sine starts at 0. So that's an asymptote. But this guy's first asymptote is just shifted over 1. It's the exact same graph, just moved over a little bit. Does that make sense? Now it starts at 1. That's it. That's it. Last one, best one. Can we put it all together? I think you can. Y equals 2 cosecant x plus 3. This, the other one was SEC. Yes, is that ready? Secant. So here's what you're going to do. You're going to put all your dots for his partner sine, right? You're going to make it shift up 3. You're going to make it go up 2, right? Put your dots for sine and don't do the graph. Then put in your lava lines where it crosses the midline and then do your kiss points. That's some crazy math that you're able to do literally just because you understand how this all works. Is he singing Baby Shark? Do, 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 do. Mommy. You know, do you remember What Does the Fox Say? Do you guys remember that one? What does the fox say? Stop, I'm on the thing, Jace. I'm taping. Me?
Yeah.
Oh my God. Oh God. Yeah, I'm gonna get fired. So I'm gonna put in some dots. Here's what I know. I know I'm shifting this guy up 1, 2, 3. There's my midline. I'm putting it in. I know I'm gonna go too low and too high, right? It's sine. Gonna put those dots in. Starts on the midline. Up, midline, down, midline, up, midline, down, midline, up if we want to. Put in the lava lines on the midline now, right? Because we've shifted it up. So everywhere I have a midline dot, and look, it's on all the whole numbers. And then finally, put in those kiss points. Woo! 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 That's right. But that is that year. There you go. That's some crazy good math because you are crazy smart people. But you got it. You got this. I am stopping my recording. I'm giving you some to try tonight.